Welcome back to another learning series with Mr. Knight. Today we're going to continue with ionic bonding, but this time we are going to use monatomic and polyatomic ions. Before I go into the examples, I want you to make note of three things. The first is that monatomic ions are ions that contain only one atom. For example, sodium, aluminum, and oxygen. The other concept is that polyatomic ions are ions that contain more than one atoms. Therefore, it will be a molecule. And so we're looking at ammonium as an example, phosphate, and sulfate. The very most important concept for this lesson is that when ions are added together, the total charge must be equal to 0. Now let's look at our first example. We're going to bond sodium ion with the chloride ion. Remember, the total charge must be equal to 0. So in this example, we have a positive 1 with a negative 1, which means a positive 1 plus a negative 1 will equal to 0. Hence, the formula for this compound will be NaCl, which means you only require one sodium atom and one chlorine atom to make sodium chloride. This was a pretty easy example. Let's look at another example. We're still going to use sodium, but this time we're going to use oxygen ion. Notice in this example the charges are different. Sodium is positive 1, oxygen is negative 2. Now, if the charges are different, your objective is to make the values the same. So to achieve this, what you must do is to cross multiply, which means you're going to multiply the positive side by 2 for this example. On the negative side, you're going to multiply by 1. So if we should express this mathematically, what we will get is that the positive 1 multiplied by 2 equals to 2. On this side, the negative 2 multiplied by 1 equals to negative 2. If you should work this out, we can say a positive 2 plus a negative 2 equals to 0. So now we achieve the total charge equaling to 0. So therefore means to make this compound, we require 2 atoms of sodium and only 1 atom of oxygen. Hence the formula Na2O, which is for sodium oxide. Let's look at our next example. For this example, I would encourage you to pause the video, work it out, and see if you truly understand. Now we're going to use hydrogen and peroxide. The charge on hydrogen is a positive 1 and the charge on the peroxide ion is negative 2. The charges are different, so remember your first step is to cross multiply. So cross multiplying these two means that the positive side will be multiplied by 2 while the negative charge will be multiplied by 1. And I want you to make note before I go any further that it is O2 we're working with, but the charge on O2 is 2 minus. Now what this is saying mathematically is that 1 positive multiplied by 2 equals to 2. And on this side, the 2 negative multiplied by 1 equals to negative 2. Now the charges on both sides, they are now equal. Therefore, the sum will be 0. So to make this compound, it requires 2 atoms of hydrogen and 1 molecule of O2. Therefore, what you will get as a formula is H2. Notice the H multiplied by 2 and the O2 multiplies by 1. So it is H2O2, and that is the formula for hydrogen peroxide. Let's look at this other example. In this case, we're looking at calcium ion, which is 2 plus, and the phosphate ion, which is PO4 3 minus. There will be a next step or an additional concept to this. Very easy though, so bear with me. The charges are different. So once the charges are different, the first step is to cross multiply to try to achieve equal values on both sides. So let us cross multiply first. So on the positive side will be multiplied by 3, and on the negative side will be multiplied by 2. Now to express this mathematically, we're saying the 2 positive multiplied by 3 equals to positive 6. The negative 3 multiplied by 2 equals to negative 6. So a negative 6 plus a positive 6 equals to 0. Now, the formula, if you notice this, will requiring 3 atoms of calcium but 2 molecules of phosphate. But I want you to make note that phosphate, which is PO4, is one entire molecule. Hence, the entire thing is or should be multiplied by what? 2. So to write this as a formula, it is Ca3, and all of this PO4 will be multiplied by 2. So to express it, we must include a bracket. So within this bracket, or parentheses, Ca3 is multiplied by Ca3 because the Ca is multiplied by 3, but the PO4, the entire thing, so put that in bracket, multiplied by 2. Hence, the formula Ca3PO42 is named calcium phosphate. Now look at this example. Pause the video again, work it out, and see what your answer will be. Now assume you have worked it out. Let's jump into it. First step, the charges are different. You cross multiply. Multiply the aluminum by 2, the oxygen side by 3. Work it out mathematically. And on this side, you say 3 plus multiplied by 2 equals to 6. On this side, negative 2 multiplied by 3 equals to negative 6. Hence, positive 6 plus a negative 6 equals to 0. Now to get this formula, we require 2 atoms of aluminum and 3 atoms of oxygen. So therefore, the formula will be Al2O3 for aluminum oxide. Now let's look at this other example here. Potassium, which is positive 1, and carbonate, which is negative 2. Again, the charges are different. You cross multiply. So the potassium side, which is a positive, will be multiplied by what? 2, while the carbonate should be multiplied by 1. The mathematical expression will be 1 positive multiplied by 2 equals to 2, while the negative 2 multiplied by 1 equals to negative 2. Hence, a negative 2 plus a positive 2 equals to 0. So, we require 2 atoms of potassium and 1 molecule of carbonate. Hence the formula K2CO3, and that is named potassium carbonate. Now let's look at this other example here. Again, this is a very nice one. So again, you could pause the video and work it out and see what your answer will be. Again, the charges are different. So the first step is always to cross multiply when the charges are different, the value. So therefore, we're saying that the ammonium side must be multiplied by 2, while the sulfate side must be multiplied by 1. Mathematically, 1 positive multiplied by 2 equals to 2 positive. Negative 2 multiplied by 1 equals to negative 2. Now the values are equal, so a negative 2 plus a positive 2 equals to 0. Now, to write this down, it is the entire NH4 is being multiplied by 2. So to write this again, remember you do that, you group all of these atoms because all of these atoms are in one ion, which is ammonium. So you're going to group them by using a bracket or a parentheses. So NH4, 2 outside the bracket, and SO4, which is a sulfate, and is only 1. So ammonium sulfate is written as NH42 SO4. And now we're at the end of the lesson, and I hope you now understand how to write ionic compounds using ions, and I'm looking forward to see you in the next lesson. Stay safe.